The global supply of scandium is highly consolidated and structurally inelastic. In 2023, global production of scandium oxide reached approximately 31.0 metric tons. China controlled over 74% of this primary extraction, recovering it as a byproduct of titanium dioxide processing. Russia produced 18% from uranium and iron ore tailings. This leaves Western nations with less than 8% of global extraction capacity. Furthermore, converting this oxide into high-purity metal is a near-total Chinese monopoly. Over 90% of global metallization capacity is located within Chinese industrial zones. This concentration presents a severe single-source vulnerability for Western aerospace and defense industries. Scandium is a critical enabler for next-generation, solid oxide fuel cells. Utilizing scandium-stabilized zirconia as an electrolyte allows the system to operate at 650 degrees Celsius instead of the traditional 800 degrees. At this lower temperature, the scandium-stabilized electrolyte matches the ionic conductivity of conventional materials. This thermal reduction decreases the degradation rate of metallic interconnects by up to 50%. As a result, operational lifespan doubles from 40,000 to over 80,000 hours. Lower temperatures also permit the substitution of expensive nickel-based superalloys with cheaper ferritic stainless steel. This shift reduces stack manufacturing costs by up to 25%. The commercial scaling of these fuel cells is threatened by severe economic friction. Global demand for scandium oxide has grown at an annual rate of nearly 13% since 2016. This demand is driven by fuel cell commercialization and aerospace alloy production. However, inelastic supply has forced prices up to $4,100 per kilogram. A standard 100 kilowatt fuel cell stack requires up to 2 kilograms of scandium oxide. At current price levels, raw material costs threaten the economic viability of the technology. Without domestic extraction and refining capacity, Western energy transition plans remain highly vulnerable to this concentrated supply chain.